Good to see so many people. Demo session. Can you go to the next slides? Yeah. This is a demo session as part of the DiSSCo Transition projects. So we have to show this disclaimer that the opinions expressed here are for our own opinions and not the opinions from the European Union. Can you go to the next slide? Yes. So the agenda for this meeting, we will have some demonstration sessions from Sulaine and Tom about the work that they have been doing in the past 2 months, and Sam will also tell us about the status of the OpenDS data model. It is now at a 0.4 version. Yeah, this is a bi-monthly meeting from the DiSSCo development team at Naturalis. We want to showcase to the DiSSCo stakeholders what has been been implemented in the last 2 months to updates and to also get some feedback. So we aim to have some time for discussion at the end of this session. And these sessions will be recorded, and the recording is available on our DiSSCo.tech platform, so that people who cannot attend the meeting can look at the recording afterwards. Next slides. So the aim is to the deliverable 3.1. This is a minimum viable product of our core specimen data infrastructure, which will be delivered at the end of the DTP projects. But there will also be updates on other projects, in particularly Tetris, in which the team is also involved. And we will also mention a short look in towards the future with things that we are planning for the coming period. Sam, can I give you the floor?
Yeah. So let's start. We always start with this slide just to do a quick recap of how we see DiSSCo as a platform. So we always try to envision what we have in mind and how we're working towards it. So we'll not spend too much time on this, but we have data providers on the left side with the collection management systems and the digitalization suites. And we'll have data consumers on the right side, where we push data to or can collect data at the DiSSCo infrastructure. And we'll have DiSSCo in the middle, where we have human agents working on the platform. So we've spent time on Discover, on getting annotations from human agents. And on the other side, we have the machine agents. So these are machine working on the specimen information. And this is all built on top of the DiSSCo core infrastructure. And DiSSCo core infrastructure collects and harmonizes the data to the OpenDS. So we've spent a lot of time the past 2 months on enhancing the Open Digital Specimen. We'll mint PIDs in the form of DOIs and handles. We'll version the data and provide all the provenance for all the data. We enable you to annotate the data. So this is where we will Tom will display about data annotation. You will be able to extend the data to the DiSSCo core infrastructure and link it to external resources. And we'll expose the data, which is part that Sue has been working on getting data out of the DiSSCo core infrastructure. And then this is what falls under the team. So we'll do the DiSSCo core infrastructure and provide all these services in the core infrastructure. And we'll provide Discover, which is the human-facing interface of DiSSCo. At least the first user, because you can build several different user interfaces on top of the APIs that we'll provide with DiSSCo. And we'll have one machine annotation agent, which will not go into too much depth in this session, but we have discussed this in depth in previous demos. So what's new? We have made quite some achievements, but most of the achievements are on the data modeling side. So that's where we'll start as well. So the FDO profiles have been updated to version 0.1. We're quite happy with this. So these are now available on our schemas pages. And this is how our FDO profiles, which is part of this wider fair digital object landscape will look like, and we've also aligned this with DataSite, who will host our DOIs. So we're happy that we're finally to a final version for this, and with that version we can move to first production. The open digital specimen, we have had an open review, which I will go into a bit more depth in a minute. And we have incorporated feedback, and we created a new version, the 0.4 version. And this is also the version with which we'll go into production. It won't be final, won't be a 0.1, a final version yet, because we know there are some gaps, but it's good enough to start making this jump and start moving to production with it. We've implemented auto-accepted annotations, so when data gets created or updated by a source system, we see those as annotations. So basically, you can think of the specimen only with the DOI, and then the first bulk of information comes from the source system. We see that as an annotation, but we automatically accept that annotation because it comes from a reliable source, but we still will provide provenance on it. So we'll say who created the new information, which is in this case the source system, who accepted the information, which is DiSSCo is automatically accepting the information. So you can always trace back how that process went. And the same with new information coming from source system, will at this moment automatically accept that information, but still create an annotation for it as well. So we have this kind of automated auto-accepted annotations. We improved the entity relationships between the digital specimen and media. This sounds relatively simple, but it's a lot of work has been put into it, especially by Sue, because there is a kind of loop where we mint identifies DOIs for digital specimen and for digital media, but they both need each other's DOIs to create that tight relation between the two. But we're really happy that we got this fixed. Annotation wizard, Tom will go into a lot of depth. And don't believe we have any additional slides, but on the Tetus marketplace we have improved a lot on the data model and integrated the form for adding taxonomic services, which is quite a big step because it was an external form, but it's been now integrated into the Tetus marketplace. So quickly, open digital specimen. The public review closed on the 11th of September. We have gotten about 50 feedback items, mostly through GitHub. You can check them all there if you want. About 10 different reviewers, with some providing 1 or 2, and especially David Wiegmuller. I don't think he's in today, but he provided a lot of feedback together with his colleagues, which we're really happy with. So it's really nice to see people interacting with it and get feedback, get new ideas, and it triggered us to look at more depth at certain parts as well. So we have gotten feedback on the data model, so really the underlying data model as well on the documentation pages, and we improved both of them in the last couple weeks and months, which resulted in this new version. So a massive thanks to anybody who's put in the effort to look through it all. We know it's a lot. You see the picture here on the right side, the class diagram. We know we have, I think, about 300 terms in this, only in the digital specimen, and then we have lots of other objects as well. So, we know it's a big task. The changes have been published yesterday on dev.terms.disco.tech. So this now reflects all the feedback that we've gotten in the public review. And our latest version on schema.disco.tech will now point to the 0.4 version instead of the 0.3. But the 0.3 is still available. So if you're using those schemas, I don't think a lot of people are, but we have certainly seen our schemas pop up on several different places. If you're still using them, they're still available. But yeah, we will deprecate them at some point. So the biggest changes, we make a much more use of a generic agent object. So we work to create a generic agent object, which an agent can be an organization, a person, or a machine. And instead of having text information into specific fields, we remove those fields. Easiest example is recorded by, which is a Darwin core field. we actually remove that field from the data model because we don't want that string field. We want an agent object where we will fill in the recorded by as the name of the agent. But with the agent, you can add a lot more information and you can add a lot of identifiers. So if you added, for example, the Wikidata identifier as well to your data, then because we also make much more use of our identifier object, you will not only see the agent name, but you will get an agent object with the identifier and an identifier object, and the identifier object will give you more information about the identifier. So it says the type of the identifier, how you can resolve the identifier, and any additional information we can find about this identifier. So yeah, more relationships, but I think also makes it more available. So more information will be available and traceable. We noticed that we could improve our alignment between our digital media object and the audiovisual core, the TEDWIC standard. So we added a bunch of fields from audiovisual core into digital media, at least the ones that made sense for us. We made some changes in the naming conventions. So before the identification was has identification, but this has become plural. So all arrays are now in plural. We moved material entity and renamed this to specimen part. This is a big discussion we had, but specimen part you need to see as a part of a specimen which doesn't have a unique identifier in itself, because otherwise it would be a digital specimen. So it's really just a tricky concept still, and we have seen a couple examples, but we haven't seen it really modeled anywhere on a good basis that we can use. So yeah, we have discussed it, and this is what we come up with for now. So it's a piece where if you have a large rock with several fossils on it, but these fossils didn't get their own identification number, there's still a way to indicate the identifications of those fossils, for example. Approved description and examples, and we switched the ODS ID to DC terms identifier. So this is mainly the DOI for the specimen. We created our own ODS ID field for it, but it was pointed out to us that this is really the same as the DC terms identifier. And for other objects, we use schema identifier. Depends a bit on, for certain objects we are a lot more DC terms oriented, and for for other objects we're more schema oriented. So that's a small difference in that part. Well, what are the next steps? So we're going to finalize OpenDS. We're gonna set this up and implement it through the whole chain, so that the new version that will move to production will contain the latest version, the 0.4 version of OpenDS. And why not go to 0.1 version? Because we know there are still a couple of improvements we would like to make, but we need further discussion with either TEDWIC groups or set up our own groups to fill in these gaps we still have in the data model. And these gaps, we know we want to improve on geological specimen, but there are just not much standards out there that we can build upon. So we know the TEDWIC mineralogy extension group, task group is working on this, and we want to align with them and talk with them. We're already having discussions about controlled vocabularies, so we might need additional terms to house those controlled vocabularies. And we're working on the publication of the terms. And yeah, we're looking into if we need a more semantic model for capturing the OpenDS. And this is, I think, where I will give the floor to Sue.
Yeah, thanks, Sam. So keeping in line with the theme of data model finalizations, we have produced a version 1.0 for our FDO profile. So FDO is Fair Digital Objects, and these profiles essentially define what metadata is in a persistent identifier record. So if I back up a little bit, like Sam mentioned, we're minting DOIs for digital specimens and digital media, and we're minting handles for annotations, machine annotation services, source systems, data mappings, and any other objects that aren't meant to necessarily be citable. But both DOIs and handles, they're kinds of identifiers that use the same resolution system, where if you click on a link, if you try to resolve a DOI or a handle, it will go to a record that contains the location of the object, and then you will be redirected to the location of the objects. The idea is the record can be updated anytime the object moves, and it should always point to the correct location, a persistent identifier. But FGOs asked the question, well, what if we could add more metadata to this record? What if instead of just the location, you could include information about the type? What can an agent expect to receive on the other end of the URL or the location? And so the idea is that machine agents, without having to go through that extra redirect, can already know how to process the data, or if it wants to make that extra step. So the FDO profiles determine what metadata is in that record, and it's type dependent. So a digital specimen will have a different profile than from a digital media, and so on. Yeah, so those JSON schemas are available on schemas.DiSSCo.tech. All of the links are at the end of the slideshow. Yeah, so that's a milestone. Next slide. So with DiSSCo minting all of these DOIs for resources, how do they get back into the source system? We're creating DOIs that can be cited, but then what if the collection manager or someone else wants to be able to ingest that back into their systems? So we're creating a tool, a process to export the DiSSCo data. So this is sort of our first use case, where a user might say, okay, give me all of the DOIs and physical identifiers for digital specimens associated with this organization or this source system, or all digital specimen in the botany collection. A user will create a search query, and then they will send that to the exporter backend. The exporter backend, the first thing it does is it checks if it has already been run. So we hash the search parameters. And so if someone has already made the exact same query, we don't need to do it again. We just send them the download link and deal with that. But if the job has not been done before, we save it to a Postgres database. So it's just, we essentially use this database as our queue. We say this is a scheduled job. It was scheduled at this time, and then it sits there. Next slide. So meanwhile, the exporter backend has another job. In addition to receiving requests, it's also checking the table every 3 minutes or so. Hey, is there space in the queue? No. Is there space in the queue? No. Okay, yes. Now fewer jobs, like 1 or 2 jobs are running. We still have a little bit of room. So let's deploy a new job on Kubernetes, which is our service deployment, our deployment service. And so it takes the job parameters and it creates a new service in Java. And the export job, which is external, an external service, will only run for those search parameters. It'll look up those the specimen that meet those criteria. It'll download, or it'll write to a file and then write those results to an S3 bucket, which is just basically on Amazon Web Services. It just dumps a zip file into a bucket. And then it returns that link to the backend. So next step, when the exporter backend receives a notification, oh, this job has been completed, it updates the job to complete. It sends an email to or it schedules an email through a mail server. This is also an Amazon Web Service product, a simple email service. And then that mail server will notify the user, hey, your download is ready. You can go to the S3 storage here. Meanwhile, the export job is exits, so we're not using resources that we don't need. Yeah, so that's sort of the flow of how exporting data will work in DiSSCo. It's a similar flow for those that have downloaded data sets within from GBIF. It's a similar, well, I don't know what it is under the hood, but it's a similar flow for the user, so it should be familiar to people. Yeah, and so that's the last new feature we're working on before the MVP, and then it's going to be a lot more testing and perfecting for the release. Yeah, and another feature that we're working on is the annotation wizard, which Tom will talk about.
Yeah, so our new annotation wizard, and to quickly explain what a wizard is, I think everybody has ever been executed in Wizard before. Mainly, it's used for installation of software on your computer, for example. But we picked this concept and we moved it into Discover to make the process of making and creating annotations much easier. This was necessary because of multiple reasons. The first reason is because our data model has evolved, like Sam and Celine have been explaining, and it has become a lot more complicated and more nested. So there are lots of different levels in the data model. It's harder for users to select a target. And the second reason is, if you want to select this target with an official interface, it can be really hard to pick out, what do you want? If you type in ID and you search for ID in our data model, you get, I think, more than 20 hits because there are like so many different identifiers present in the data model, and they all have a different purpose. So with this wizard, we introduce a few steps that really help the user to target the correct term in our data model, and also to target the correct instance, because you can, of course, annotate the same attribute or property multiple times, and other people can also annotate in a property. So we really want to streamline this process. So there are 4 steps in the wizard. So first we define your targets, and then you choose an existing or a new instance, and then enter your values to be annotated, and then review and save. And I will just show you in a minute, but we also predefined some annotation cases, which I can show you in practice. And these cases are what we think often use classes and terms in the model. Like, for example, georeference. If I know a location of an object and I easily want to inject a georeference into as an annotation, I don't want to search for the georeference object in our data model, but just quickly say, I want to add a georeference, bring me to the menu so I can do it. And these cases help with them. They're like shortcuts to these targets. Next slide, please. So to visually show how this would work, the annotation wizard targets different things in the data model. Saying, for example, I can target the class event if you click Sam. But I can also target the georeference, like I was just saying, and so on. So if you click further, you can target the superclass. So that's like the most upper class digital specimen, or individual terms like specimen name. And all these different levels have their own path towards it. And the annotation wizard remembers the path and uses this path in the annotation object that finally gets published to our backend. And this path is really important because it contains all the necessary information that's needed to point towards the correct targets and also the correct instance. For example, you can have multiple entity relationships. And our first entity relationship is to gbif, so that has an identifier of index 0. And we have another one that points to geocase, for example, that has index 1 or index 2. And this path also remembers these identifiers as pointers. If I could get the screen, Sam, I can show.
Should be able to. Excellent.
Yeah, is it visible?
Yeah.
Cool. So first off, I'm showing you the old version to show how we improved on it. So in the old version, if you want to add an annotation, you would have to search through like this whole list of classes or this mega long list of terms. And you could, of course, search, but then if I search for ID, you get like the issue I just pointed out. You get loads of different identifiers. And if you would select one, so if I select material, what does not exist anymore, but if I would select citation, for example, and annotate a new one, I will just go to this menu, which has, these fields, and it doesn't really help the user that much. and doesn't explain what you need to do. Well, you can enter some values and then continue. But what does this do and what's the effect of it? It doesn't explain that. So in our new version, we really try to emphasize this process. So if I now add an annotation, you can already see that the menu is a bit different, and there are 4 steps at the bottom, and every step will be a little part of making your annotation. So the first step is to define your annotation target, and we can use 2 different methods for this. First, we have our benchmark classes, which is like the shortcuts I explained, the annotation cases. Or we can make an advanced selection. And this one is very similar to the old one, but we improved on it. So if you, for example, select agent, it will filter only on the agent properties to make it a bit easier. But these shortcuts are very useful. So I pointed out georeference. So if I want to add a new georeference, I just click on it, and it goes to the next step. So we already set a target on georeference. Our second step is to define, okay, which instance of the georeference do I want to annotate? In this case, we only have one. So we have one event with as a location and georeference silence. So if you want to annotate this, we select this instance. And then we get to the third step, which is defining your values. So to quickly explain, this is a class instance. It also says class. And if you select a class, it will display all the fields that are inside this class instance. So these are all individual fields that appear inside the georeference. So for example, we have our latitude and longitude here, which you can annotate. But also all the other properties. So I would add, if I would add something here, something random, which doesn't validate at the moment, which is just a free text string, and click on next step, you will go to your final 4th step, which is like a summary, and saying, okay, well, this is what you're going to annotate. So we are still annotating on this class, and this is what is going to be inside our annotation. So we had these values type and geodetic datum, which were already in there, and we just added the verbatim coordinates, which is like marked in blue to indicate that it's a new value or new property you're going to annotate. And if I save the annotation, it should save the annotation. I want to quickly show, so there it is. Quickly show you some different examples. So you can also have really nested classes. And well, this is not a good example anymore because now we have specimen. It has changed. If I would select event, which is a really nested class, and make a new one, you get event, and you also have lots of subclasses in event. So these are like the different levels I just showed in the presentation of the object in the schema. So an event has, for example, a location subclass. And if you go all the way down, we see, okay, look, georeference is still there, but it's nested all the way down inside this location. But the interface really tries to help make clear that these different levels are different levels in the data model, and that you can annotate these different levels, but based upon your target. So now we're really high up in the events, but if you go back and select georeference again, we're back into that georeference level of the data model. So if I would select event, and then the first one, and we would go down to location, and then to georeference, you see the same values are here as in the other georeference we showed, because it's the same one, only now we're targeting the event the georeference is nested in. So it's really comprehensive, and trying to display all these different levels of the schema, which already also makes it hard to understand. But that's why we try to provide explanations via this wizard. I think that's it, Sam.
Yeah, thanks. Yeah. Let me take over the screen again. So, yeah, we will be constantly improving on these on the annotations. We know that there are a lot of possibilities there. We have a big data model, and annotations is a very flexible concept. Adding this piece of information to any part of any of the objects. But we're trying to iterate and make it easier and easier for users to align with how users will actually want to work, while still keeping the possibilities to have all the functionality there. So that we'll keep iterating on this, especially when we go live and get some user feedback in on how the user actually want it to work, and then improve upon it. Yeah, thanks, Tom. Let me share again. Let's do a quick look forward. There we are. So looking forward, we're implementing the OpenDS 0.1 in the whole infrastructure chain, so that all the things will be propagated both in the backend, in the data storage, as well as in the front end. And we'll continue on working on the front end improvement. So we now have got most of the annotations part in that Tom just showed. And we're now working on also getting machine annotation services going and filling out more of the blanks. So now what Tom showed, you still saw a lot of blanks in the specimen page. So we're trying to fill those out and put primary information of the specimen in the first landing page. So you see all the most important information there. We're creating documentation for supplying data, metadata, because at the end of this year we want to go live and start with a couple suppliers, and have them get data into DiSSCo. Finalizing the DiSSCo data exporter. So it was a really excited first step. So we first have the small use case, but we built it generically. So basically any exporting job could run through this system. And the exporting job is basically something that gets some data, either aggregated or some part of the data, out of the DiSSCo infrastructure into a separate file, which you can then download and share, or you can share the link with your colleagues. So it's another way of getting big parts of that data out, and if need be, into your own infrastructure or put it somewhere else. So we set it up generically, so others could also create exporting jobs, and we could run those as well. We're helping the mass providers. So we had talks with Jonas and Klaus and his team to see how they can connect their machine annotation service into the DiSSCo infrastructure, so that when we move to production, we can have some machine annotation services in there where users can test those services and see how they function. Another big move is observability. So this includes monitoring, logging, auditing. Is our system up? Are we experiencing any exceptions? What are users doing? And all those kind of things. So we're moving this to an observability stack that Naturalis is hosting, Doorplace, based on OpenTelemetry, open source solution, which looks very promising. So we're looking forward to working with them on that. And one of the things we require from our users is that they add an ORGID to their account. And when users log into institutional accounts, we don't always have the ORGID. So we need some button where users can, through a validated link, go to ORGID and connect their ORGID to their account. So this is something we need to implement, so we can always trace back annotations to a unique identifier, which is the ORGID for persons. Tombstoning. So we've put a lot of work in tombstoning also in the new data model, and when things are tombstoned and what information we need to capture when something gets tombstoned. For example, if it's merged into another specimen, then we want the identifier of that new specimen into the tombstone information. So we'll work on tombstoning those, and then we need to extensively test the MVP before we go live. So we're now closing up with the last features, so that we hopefully by the end of this year have a good set of Discover and the DiSSCo core infrastructure with which we can go live and really start minting the first DOIs for a specimen and get first annotations in. On the side, we're working on a vocabulary server and a controlled vocabulary, seeing how we can include those. This is still an open point, but we're discussing it with several partners on how they're doing controlled vocabularies and if we could align our approaches to this, so we can make it a bit bigger to the whole community. And that's Marketplace, the deliverables coming up, I think at the end of this year. So they're working towards the last deliverable, getting the last pieces in place so that this Marketplace can also go be finalized. And what I want to mention is that on the 30th of October, there will be a workshop. I think invites have already been sent to the national nodes, where we'll look at prioritizing the next steps. So what we're going to do after the MVP, what are the priorities? We have a long list of things we can do, but we need some input on what the highest priority is and where DiSSCo needs to be heading. And with that, I think it's time for discussion, questions. Any feedbacks, welcome. Feel free to pick up the mic and tell us what you think. Let's see. Yeah, if there are no further questions. Oh, wait for a second.
Sam, it might be beneficial for the audience to maybe further explain the reason for tombstoning. I don't know if we discussed it last time.
Yeah, that's good. Yeah. So, the concept of tombstoning. So a lot of users know, I've got this no deletion. So I've created an annotation and I don't want it anymore, and I will delete it. But the one of the things with persistent identifiers is that they're persistent, and we have minted these identifiers, and we've minted these identifiers, so they need to be resolvable. And we have the information in our system, and basically instead of deleting all the information from our system, we'll flag that information and say, well, this information is no longer active. So each of the objects have a state as well, saying whether it's active or not. And when it's been tombstoned, we'll capture the information about who it was tombstoned, when it was tombstoned, what the reasons are, where you can go if you want to find additional information. So we get all that information, but we'll still keep the annotation in our system, let's say. And if you go resolve the identifier, the persistent identifier, you will still land on a landing page where you can see what the initial information is, but also see the reasons why it was tombstoned. So we're not losing any information. If you cite information which will later get deleted, then the information will still be there, but it will be tombstoned. And you can still resolve the link and still see all the details that were initially there, but you will get a big red marker on the page saying, well, this is no longer active information. This is tombstoned information, basically. Yeah, so that's a bit of a difference between. Matthias asked a question, will the tombstone data still be findable index? No, we remove them from the index. Yeah, at least until there's a use case that people actually want it. because a lot of things on the index will provide metrics. So yeah, people will see what their MIDS levels are, or how much of their data has been digitized, distribution over different topics, and you don't want those metrics being spoiled by tombstone specimen, because there was once a data set for which we minted a lot of DOIs, which was then rejected or retracted. So yeah, it's no longer indexed, but it's still in the historical part of our system. Yeah. And I think there was an additional question. Yeah, thanks, Matthias, from you as well. So the exporting service, yeah, this will be a zipped export. It will probably be stored indefinitely. It definitely is a bit of a big word, but we don't think we have set a storage time yet. And at the moment, we will not get a PID. Yes, sorry.
Just to add to that, so likely if something has been inactive for a certain period, we've talked about moving it to a long-term storage like AWS Glacier, which is very, very cheap, but it also takes some time to retrieve it if you do decide you want it. And in terms of whether or not they get a PID, right now they get a UUID, but it's possible as the use cases for jobs expand, some things might want to be citable. And some aren't. So currently no, but there's the option in the future.
Yeah, so I think it depends on how what the user needs will be there, how people are going to use this. So currently, I think we see this as a way to export some data that you can ingest that data in your CMS to update your data and things like that. But we do not currently see this as a way to cite that as a data set in your publications. We expect that the data, once it is of sufficient quality, goes to GBIF and or to GeoCase, and you will cite data sets from there. Yeah, but this really we need some user feedback there to see what is needed, and we could give them a PID if that is needed for some use cases.
Yeah, I guess you could also work with Zenodo, and they can be archived there if a PID is needed with a DOI. To come back to the tombstoning, one use case for indexing in some way, at least, the tombstone data is if people want to find what has been tombstoned, and in particular, why. Because if you have a snapshot of earlier data and then you find that some of these records are now gone, you might want to find out why and what happened to them. And oftentimes in infrastructures, tombstoning indeed is not indexed at all. And you just have to resolve all of those different identifiers to find this information. So that's one of the use cases that I have encountered in the past myself with other systems.
Yeah, that's a good comment. Yeah. So yeah, if we get that use case in, then we could always, it's basically still the all digital object is there, but we add tombstone information to it and update the status. So we could create let's say a duplicate index for digital specimen with only the tombstone information. That's still very much doable because it's basically the same object. But we don't do it at the moment. No, but the option is there, and if we get the use case in, then it might be possible. Yeah. Oh, yeah, Stefan, thanks. Yeah, that's a good question. How is the specimen part defined? Is it a physical separate object of the specimen, a region of the specimen, a physical different composition of the specimen? Yeah, I don't think so. We know that there are specimens which are composed of really multiple different other things, different organism, if you want to say, but that's already a bit harder with the geological specimen. For example, I've modeled this also based on a large rock which had 3 minerals on top of it. but only the rock itself had gotten a number, a registration number, a catalog number, and the three different minerals didn't had any unique identification or registration number. And the basic description that was in that system was saying, well, this is a rock with these three minerals on top of it. But yeah, that's very hard to find. What you want in essence is saying, well, this is the digital specimen itself, which would be the whole rock itself. But it has three parts which don't have a unique identifier, because if they have a unique identifier, you could say they're different specimen in itself, so create a different digital specimen of them in itself, and then link those two to entity relationship, saying, well, this specimen is part of the other specimen. But if you don't have a unique identifier for it, you have no idea to indicate that these two are together, or that this is part of the other. So then we say it's a specimen part, and then you still can have measurement on that mineral and have identifications, which I think will be really important for those minerals. And that will be indexed. So if you search for those identifications, you will still find your specimen. But you can still describe those parts of the specimen as separate things in itself and make assertions on those and make identifications on those. But as I said, I don't think there's any way that you can do this at the moment with Darwin Core or with ABCD. Although their similar structure is a bit used, but I've never seen it actually being used. So yeah, we have space for it, and we know there are use cases out there, but we still need to see how the actual implementation will work. So I would normally say that if it's a physical separate object, that physical separate object should get its own catalog number. And if it doesn't, then there's an issue, because it can also be stored somewhere else, basically. But if it's a region or a different composition of the specimen, then I think there are organizations that don't create a unique catalog number for those, but still need a way to describe those different regions of the specimen, let's say. I don't know if that answers your question sufficiently.
Yeah, thank you. Let's just thinking about, because in diversity workbench we have the same concept mode. Yeah, we have specimen part, but we have also specimen unit, which is a little bit different in our case. But I think it's more the specimen unit which then connects here to this schema. Yeah. Thanks, Sam.
Do you have a description of the schema that you use?
Yeah, of course.
Could you send it to me?
Yeah.
Then we can have a look at it as well, because we're always interested in how others are modeling these concepts, because it's tricky to find a generic enough way to get everything in that's still specific enough that everybody knows what you mean.
Yeah, I will send you.
Yeah, thank you. Any further questions? Okay. Then I would say in the slides are additional resources. If you want to look at all the schemas or the further earlier blog post or the documentation pages, feel free. And if you have any additional comments, send an email, create a GitHub ticket. Reach out to us, and we'll see if we can answer your questions or incorporate your feedback. And let's see. Don't think we picked. Yeah, we picked a date for the next one. Or quickly share it, which will be the 18th of December, which will hopefully be just before we move to a first live version. So hopefully we have made a lot of ground by then, covered a lot of ground, and can show you first how the first production version will look like. And thanks for attending.